Welcome back. In this module, we talk about Zero Trust Architecture, a modern security philosophy. As the traditional security perimeter collapses, organizations face an unavoidable question. If location can no longer be trusted, what can? Zero Trust emerges as an answer to that question, but it is often misunderstood. Zero Trust is not a product. It is not a single technology, and it is not a checklist that can be completed and set aside. Zero Trust is a way of thinking about security in environments where assumptions about safety no longer hold. This section introduces Zero Trust as a security philosophy, one that reflects how modern systems are actually used, accessed, and abused. Why Zero Trust exists? Zero Trust did not arise because organizations wanted stricter controls. It arose because the old controls stopped working. Perimeter-based security assumed that once a user or system crossed a boundary, it could be trusted. That assumption made sense when systems were centralized, networks were well-defined, devices were controlled, and access paths were predictable. As those conditions disappeared, attackers adapted. They stopped trying to break in from the outside. Instead, they focused on obtaining legitimate access through stolen credentials, phishing, compromised devices, or third party connections. Zero Trust exists to confront this reality. Never trust, always verify what it really means. The phrase most commonly associated with zero trust is never trust and always verify. On its own, this can sound harsh or impractical. Zero trust does not mean that nothing is ever trusted. It means that trust is not assumed by default. It is established deliberately, continuously, and with evidence. Access decisions are based on verification, not location. Trust is conditional and revocable. This is a fundamental shift from implicit trust to explicit trust. Least privilege as a foundational principle. One of the core principles of zero trust is least privilege. Least privilege means that users and systems are granted only the access they need to perform their function, nothing more, and nothing permanently unless required. This matters because most damage in cyber incidents occurs after initial access. If an attacker compromises a credential with broad permissions, the blast radius is large. If access is tightly scoped, movement is constrained. Zero Trust does not assume breaches can be prevented entirely. It assumes they will occur and designs systems to limit their impact. Continuous authentication, not one-time approval. Traditional access models rely on a single moment of authentication. You log in, you're trusted, access continues until you log out or the session expires. Zero Trust challenges this model. In zero trust environments, access is evaluated continuously. Context matters. Is this the same device as before? Is the behavior consistent? Has the risk profile changed? Is the request appropriate for this user? Authentication becomes an ongoing process, not a one-time event. This allows systems to respond dynamically as conditions change. Identity and device as central signals. In Zero Trust, identity is central, but it is not the only signal. Device health, configuration, and posture matter. A request from a trusted user on an unmanaged or uncompromised device or a compromised device is treated differently from one made on a secure, compliant system. This reflects reality. Trust is not binary, it is contextual. And zero trust frameworks combine multiple signals to make access decisions that reflect actual risk. Micro-segmentation, containing movement. Another key concept in zero trust is micro-segmentation. Rather than assuming that internal networks are safe, systems are segmented into smaller isolated zones. Access between these zones is controlled and monitored. This limits lateral movement. If one system is compromised, the attacker cannot automatically reach everyone else. Each additional step requires authorization. Microsegmentation turns internal environments into a series of controlled interactions rather than a single trusted space. Why zero trust is especially relevant in cloud and remote work. Zero trust aligns naturally with cloud computing and remote work because it does not rely on physical boundaries. Cloud services are accessed from anywhere. Devices change, users move, integrations expand. Zero trust treats all access as remote access. This consistency reduces complexity. It allows the same principle to apply whether someone is in the office, at home, or halfway across the world. Security becomes location agnostic. Zero trust is about design, not distrust. One of the most common criticisms of zero trust is that it feels hostile, as if it assumes users are malicious. This interpretation misses the point. Zero trust does not distrust people, it distrusts assumptions. It recognizes that credentials can be stolen, devices can be compromised, and contexts can change without malicious intent. Designing systems that account for this is not punitive, it is responsible. Good zero trust design reduces friction for legitimate users while increasing resistance to abuse. Why zero trust is not a single implementation? Organizations often ask whether they have implemented zero trust. This question reflects a misunderstanding. Zero trust is not a state you can achieve, it is a direction you move forward. It influences how access is granted, how systems are segmented, how identities are managed, and how incidents are contained. Different environments will adopt these principles in different ways. What matters is alignment with the philosophy, not adherence to a rigid blueprint. Zero trust and organizational reality. Zero trust does not eliminate risk, it reshapes it. It accepts that breaches will occur, credentials will be compromised, and devices will fail. The goal is not perfection, it is resilience. By reducing implicit trust, zero trust reduces the consequences of inevitable failures. This is why it has become a cornerstone of modern cybersecurity strategy. Why this matters beyond technology teams. Zero trust affects how work is done. It influences user experience, vendor access, system design, and governance decisions. Poorly implemented zero trust can create friction. Well designed zero trust can enable flexibility without sacrificing safety. Understanding the philosophy allows non technical leaders to evaluate trade offs intelligently rather than reacting to buzzwords. The key takeaway here is zero trust is not about locking everything down. It is about removing blind trust. In environments where location, devices, and networks can no longer be assumed safe, trust must be earned continuously, not granted once. Zero trust replaces outdated assumptions with contextual verification. It reflects how modern systems are actually used and attacked. As a philosophy, it provides a coherent response to the collapse of the perimeter and a foundation for modern cybersecurity thinking.